Everything you need to know. Basic work problem, Democrat versus Republican. And this is a very special work problem that I created to specifically teach you how to work a difficult work problem. And so let's get started. Okay, let's review the basic work problem. And I realize I performed this previously in a previous video called Work-Related Problems or Work Problems. So, but I want to review this again because I'm going to go into more detail about this work problem. So, okay, let's say you paint a room in your home in 4 hours. So now let's determine how much of the work you get done per hour. So let's divide this job up into equal parts. Since the entire job takes 4 hours, equal parts per hour would be, and we created a table. So to get the total work completed in the first hour, we have 1/4 of the work done. In the second hour, we have 1/4 of the work done. In the third hour, we have 1/4 of the work done. And in the fourth hour, we have 1/4 of the work done. And if you add all of that up, you get one job completed. Assuming that you work at the same speed for the entire job, this task per hour is called a work rate or task rate. Therefore, work or task rate equals rate times time. And so we abbreviate that by saying W equals R times T. And if we divide through by T, we get rate is equal to work divided by the time taken to work the job. So work is equal to work or task to be done. Rate at which you do the work is R, and T is time to get the work done or to do the work. So the total task is equal 1/4 task per hour plus 1/4 task per hour plus 1/4 task per hour, and that equals to 1 if you add those up. Let's continue. Okay, rate can either be task per hour, task per month, or task per year, etc. So let's solve a problem and draw a table to see what we're doing. Example problem. Ellen can paint a fence in 4 hours. Jane can paint the same fence in 5 hours. How long will it take to paint the fence if they both work together? Let's let X equal the number of hours required by Ellen and Jane working together to get the job done. Okay. So we have workers, Ellen and Jane, and we have rate equals work divided by time. We have one job divided by, for Ellen, we have 1/4 of an hour, because she can paint a fence in 1 hour, 4 hours, so we have 1/4 of an hour. We have Jane can paint the fence in 5 hours, so we have rate of work equal one job divided by 5 hours, so that's 1/5 of the fence per hour. Okay. And so the time working together is X sub T, and the work or the task is equal to 1/4 plus 1/5 equals 1/T. Let's break this equation down and explain it in detail. So here's our same problem. Ellen can paint their fence in 4 hours. Jane can paint the same fence in 5 hours. How long would it take to paint the fence if they both work together? Rate equals work divided by time. So W is equal to paint one fence. Time equals time working together. And R equals rate of work. So the rate of work for Ellen is she can paint one fence, 1/4 of the fence per hour. And Jane can paint 1/5 of the fence per hour. Therefore, we write the equation W over T equals rate, and we write in the rates for each of the workers. 1/4 of an hour for Ellen plus 1/5 of an hour for Jane. So 1/4 of the fence per hour for Ellen and 1/5 of the fence per hour for Jane. And W is equal paint 1 fence. Okay. So therefore we end up with 1 over T is equal 1/4 fence per hour plus 1/5 fence per hour. Let's continue. So here's our same problem. And here's our previous equation. We solve for the fraction. We solve for T. Well, we have 2 fences in here, so we can cancel the fences out. We invert and multiply. And the total time is equal to 2 hours, 13 minutes, and 20 seconds. Let's continue. Let's change the problem. Let's say there are 10 Ellens that can paint their fence in 4 hours and 15 Janes that can paint the same fence in 5 hours. How long will it take 1 Ellen and 1 Jane to paint the fence if they both work together? Okay, so we write our equation. Rate equals work divided by time. Work equals, as previously, 1 fence. Time equals time working together. R rate equals rate of work. And for 10 Ellens, we have 1/4 of a fence per hour because that's what 10 Ellens can paint. They can paint a fence in 4 hours, so 10 Ellens can paint 1/4 of the fence per hour. And 15 Janes can paint 1/5 of the fence per hour because 15 Janes can paint the same fence in 5 hours. Therefore, we write the equation and we insert our rates, and W is equal 1 fence. So therefore, 1 over T is equal 1/4 fence per hour plus 1/5 fence per hour. Same as previously. Exactly the same as the previous problem. But this time we have 10 Ellens and 15 Janes. But we said 10 Ellens can paint a fence in 4 hours and 15 Janes can paint the same fence in 5 hours. Let's continue. But we don't know the work rate of each individual Jane and Ellen that does the work. So here we have 10 Ellens that can paint 1/4 of the fence per hour. And here we have 15 Janes can paint 1/5 of the fence per hour. Therefore, we write the equation. We got to divide by 10 on both sides of the equation. So each Ellen can paint 1/40th of the fence per hour. That's the individual work rate of each Ellen. Let's continue. And here we have 15 Janes, and we divide through by 15 on each side of the equation. And now each Jane can paint 1/75th of the fence per hour. Therefore, we write the equation and we include our work rates. Therefore, each Jane has 1/75th of the work done per hour, and each Ellen does 1/40th of the work per hour. Let's continue. So here's the question. There are 10 Ellens that can paint a fence in 4 hours and 15 Janes that can paint the same fence in 5 hours. How long will it take 1 Ellen and 1 Jane to paint the fence if they both work together? And there's a special reason why I'm going through this problem like this, so you'll understand how to separate that problem, and you'll see how this works out. So therefore, we write the final equation. How long will it take 1 Ellen and 1 Jane to paint the fence if they both work together? And we write that out as such. W task over time equals 1 Jane plus 1 Ellen rate. And we include the Ellen rate and Jane rate. The Jane rate is 1/75th pence per hour, and the Ellen rate is 1/40th pence per hour. And where W task equals 1 fence, therefore, solving for the total time both Jane and Ellen work together to paint the fence, we multiply by total time T. And we solve the fractions. Let's continue. Here's our previous equation. And we invert and multiply. We divide and invert the fraction. Therefore, solving for the total time both Jane and Ellen work together to paint the fence, we get where for one Jane and one Ellen working together, the total time equals 26.086 hours. Now, let's change the problem again. Let's say there are 10 Ellens that can paint a fence in 4 hours and 15 Janes that can paint the same fence in 5 hours. How long will it take 5 Ellens and 6 Janes to paint the fence if they work together? We've already determined the painting rate for each individual Jane and Ellen. An individual Jane can paint the fence 1/75th of the fence per hour, and Ellen can paint 1/40th of the fence per hour. Therefore, we write the equation for 5 Ellens and 6 Janes. We write 5 times the Ellen rate plus 6 times the Jane rate equals 1/T. And we insert the rates. Let's continue. Here's our previous equation. Let's now remove the units to have some space. Therefore, the total time for 5 Ellens and 6 Janes to paint the fence working together is 4.87 hours. Let's continue. Let's do a new problem. There are 5 men that can build cabinets in 4 hours. There's 12 boys that can build the same cabinets in 7 hours. How long will it take 3 men and 8 boys to build the same cabinets if they work together? Well, remember our equation. 5 men equals 1/4 of an hour because 5 men can build cabinets in 4 hours. And 12 boys can build cabinets in 7 hours. So we divide through by 5, both sides of the men equation, and divide through by 12, both sides of the boys equation. How long will it take 3 men and 8 boys to build the same cabinets if they work together? Well, we have 3 times the men rate plus 8 times the boys rate equal 1/T. Therefore, we write the men's equation, rate equation, equals 1/20th cabinets per hour. And we write the boys' rate equation, 1/84th of the cabinets per hour. Let's continue. The previous equation is the rate at which each boy and man builds a cabinet. Here's our previous equations. Therefore, we plug in the rates for the men and the boys into our equation. 3 men plus 8 boys. And how long does it take? We've got to solve for T. And here's our equation. 3 times the men's rate plus 8 times the boys' rate equals 1/T. Which you can see is a fraction of the original. Remember, we had 5 men can build cabinets in 4 hours. So we had 1/4 cabinets per hour for 5 men. And we had 12 boys that can build the same cabinets in 7 hours. So we had 1/7 of the cabinets per hour for 12 boys. How long would it take 3 men and 8 boys? Well, 3 men is a fraction of the 5 men. So that's 3/5. 8 boys is a fraction of the 12 boys in the front part of the problem, which is 8/12. Now we have to solve for t. Let's continue. This is our previous equation. So we solve for t. We invert. And t is equal to 4 hours, 4 minutes, and 40 seconds. Let's continue. Okay. Democrat versus Republicans. This is a special problem that I created, and we're going to use everything we've learned and learn a little bit more to solve this problem. Okay. We have Democrats versus Republicans. The Speaker of the House says his buddies, 5 Republicans and 3 Democrats, can write a bill in 16 weeks. The President says his buddies, 9 Republicans and 7 Democrats, can write that same bill in 8 weeks. They compromise and appoint 7 Republicans and 5 Democrats to write the bill. If they both work together, how long will it take to write the bill? Remember our equation. Rate equals work task divided by time. Work task equals 1 bill. Time equals time worked together. R rate equals R Republican. And R rate equals D Democrat. So the equation for the Speaker of the House is 5 times the Republican rate plus 3 times the Democrat rate equal 1 over T, and T is 16 weeks. The President's equation is 9 Republicans, 9 times the Republican rate, plus 7 times the Democratic rate equals 1 over 8T, which is 1 over 8 weeks. The compromise is 7 times the Republican rate plus 5 times the Democrat rate is equal to 1 over T. And that 1 over T is when they're working together. Let's continue. So here's our previous equations. These are the simultaneous equations. Therefore, let's eliminate the Democrat and solve for the Republican rate. So in order to do that, we'll multiply the top equation by -7 and the bottom equation by 3. If we do that, when we multiply it through, the Democrats on the bottom will be 3 times 7 is 21D, and on the top it will be -7 times 3 is -21D, and we add those together, they'll cancel out. So after multiplying and adding the equations, we get -7 times 5 is -35D, R. -7 times 3 is -21D. And -7 times 1 is -7 over 16. In the bottom equation, we multiply 3 times 9 is 27. 3 times 7 is 21. And 3 times 1 is 3. When we add these two equations together, Democrat drops out. And we get Republican is equal to, we have -8 times the Republican rate is equal to -1 over 16. We divide through by 8, and we get Republican equal 1 over 128. Divide through by minus, divided by a minus is a plus. Okay? So the Republican rate is 1 over 128. Let's continue. Now, we'll take this Republican rate and plug it into any one of these equations up here. I picked the first one, but you can plug it into any one of them. So we have 5 times the Republican rate, which is 1 over 128, plus 3 times D equal 1/16. And we solve for 3D, and we equal to 1/16 minus 5/28. Now we divide through by 3. 3 over 3 is 1. 3 cancels 3. And Democrat rate is equal to 128 also. Now substitute into the compromise equation. Here's our previous equations. The Democrat rate and the Republican rate. Now substitute into the compromise equation. Well, our compromise is 7 times the Republican rate plus 5 times the Democrat rate equals 1 over T. We substitute in the rates, solve the equations, add the equations together. That's 12 over 128 equal 1 over T. Multiply it through by T, and we get 32 over 3. And the time to write the bill is 10 weeks, 4 days, 16 hours. That's it, folks. That's a lot of power you got in this video. Everything you need to know, the basic work problem. It's not magic, it's the law. Until next time, thanks.